This is Srikanth working as assistant professor in electrical department. In this video, I will give small information on maximum power transfer theorem. So in that name, maximum power transfer to some other place. Okay, one place to another place, I need to transfer the maximum power one place to another place. So source to load. So for this we have one condition. So when the source resistance is equal to the load resistance, then the maximum power delivered source to load. So this is a condition for maximum power transfer theorem. Check the statement here. So maximum power transfer theorem states that any linear bilateral network, maximum power is delivered to the load when load resistance is equal to the internal resistance of source. So for this, I will take like Thevenin's theorem as well as Norton's theorems, small circuits. Okay, source resistance I have Rs as well as RL. Same when you have current source parallel with the resistance. So then I have load resistance. Voltage source series with one resistance and load resistance. Current source parallel with the resistance with load resistance. So then when the Rs equal to RL, here also same. In Norton's theorem also, source resistance equal to the load resistance. So internal resistance equal to the load resistance, then the maximum power delivered to the load, source to load. So this is a condition. Okay. So I will consider like a Thevenin circuit. From Thevenin circuit, how many loops we have? So we have only one loop. So how many currents? Only one current. That means V by R. So here both resistance series. So we'll get like I equal to V by Rs plus RL. So source plus load. So this is your I value. From this, can you find out the power at the load? So I need to find out the power at the load point. So I need to find out the power at load point means I square into RL. So I require the power at RL means P equal to I square into RL. So here now I am not writing like V into I. So I need to find out the power at the load means I need to write the equation I square into your resistor. That means load resistance. Just substitute that value in your equation. Then we will get like Vs by Rs plus RL whole square into your load resistance. Here your load resistance. I square is, this is your I. Solve this equation. Then you will get like V square into RL by Rs plus RL whole square. This is your power at load. But I need to find out the maximum power. So for this, just derive the power equal to 0. Then dP by dRL. This is equation for maximum. Find out the maximum power. Now, here just observe this equation, P equation. So RL means you require derivative which formula? U by V formula. You require U by V formula. So what is your U by V formula for derivative? That is V into du by dx minus U into dV by dx by your V square. So same thing. What is your V value now? So now your circuit V square is constant. So V square is constant and RL and Rs plus RL whole square equals 0. So now here what is the V value? So U value is RL and V value is Rs plus RL whole square. Am I right? So U value we have, V value we have. Just substitute in your derivative formula. Vs square is constant. So substitute here directly. Then V value. So this is your V value. This is your V value. And du by dx. So du means which value we have? RL value. So drl by drl. So dx by dx, how much you will get? Only 1. So here 1. Next minus just u value. So this is your u value. Then derivative of v value. So derivative of Rs plus RL whole square. So x square formula. Derivative of x square. That means 2 into x. So 2 into your x. X is Rs plus RL. That means your V. Okay. Now by V square. Again V is Rs plus RL whole square. That means V square means power 4. So Rs plus RL power 4. Clear? This is the equation now. Solve this equation. We'll get like a Vs 0 and this is also 0. Then common from this 2 Rs plus RL whole square. Same Rs plus RL is there. So Rs plus RL as well as Rs plus RL. So from this we'll get like 1 Rs plus RL in this point. So RS plus RL. From this minus 2 RL equals 0. So from this we will get like RS minus RL equals 0. So from this we will get like RS equal to RL. So when the maximum power will get delivered to the load means source resistance equal to the load resistance. Then we will get the maximum power at load point. We proved the maximum power transfer theorem statement. Okay. Now from this I require the what is the maximum power value and what is the efficiency also. Okay. I'll discuss about that now. Here same statement which are the RS equal to RL. Okay. Now consider like Thevenin's theorem. From Thevenin's theorem we know the I value already we discussed as well as P value also. Now just substitute RS equal to RL. So RS equal to RL equal to some resistor R. Okay. Substitute the R value in your P. So we'll get like P equal to Vs by R plus R whole square into R. Just solve this equation. V square by 4R square into R. So R cancel. R and square cancel. We get like V square by 4R. So from when you substitute that RS equal to RL equal to R, then your power. So maximum power at the like load point is Vs square by 4 into R. Okay. This is your maximum power value. Then what is the efficiency? For efficiency, we require output power by input power. So what is the output power? That is I square into RL. So output means RL. And what is input power? Input power means we need to consider to whole. So just check it the equation here. Output by input into 100. That is your efficiency. And your output is I square into RL at load point. Output means load point. And your input is I need to consider total whole circuit. So that is Vs, that means I square into RS plus RL. Just substitute same RS equal to RL equal to R. Then I square cancel. So RL is also R and RS also R and RL also R. So we'll get like 1 by 2 into 100. So how much efficiency will get now? Only 50%. So in maximum power transfer theorem, we are getting only 50% of efficiency. Assume voltage equal to some 10 volts as well as resistor is 5 ohms. Just assume voltage is 10 volts as well as resistor is 5 ohms. That means internal resistor is 5 ohms. And just vary the load resistance one by one. 1 to like 10. Just vary one by one and observe what is the current value and what is the power value. Just observe. So now suppose my resistor value is, load resistance value is now 1. Just vary the resistor value 1 to 10. Just vary now. Okay. Then now RL is 1. Just consider like as 1. So from this we will get like Vs is 10 and RS is 5 plus RL is 1. How much will you get? 1.667. And what is the power now? Power is same as like 10 by RS is 5 plus 1 whole square into your 1. So how much will get? 2.778 watts. Okay. So when the load resistance is 1 and your voltage value is 10 as well as your internal resistance value is 5, then your value is I is 1.66 amps as well as power is 2.778 watts. So this is when RL is 1. Now just increase the RL value. Now RL is 3. Just same thing. If you get the RL is 3, then your values I is 1.25 amps as well as P is 4.68 watts. Then just increase again. Now your RL value is 5. Then I is 1 as well as P is 5 watts. Then again increase to 7 ohms. Then 0.833 as well as power is 4.86. Then again increase to 9. Same 0.714 and P is 4.59 watts. Just observe those values. So I is decreasing directly, but your power is increased as well as decreased. When you have the maximum, so when RL equal to RS, then the maximum value you have. Clear? So here 1, 3, 5, 7, 9 is their RL values. So here 5 as well as RS also 5. So when the 5 and 5, then the power is maximum. Remaining time increased as well as decreased condition. Okay, when the load resistance equal to the source resistance, then the power is delivered to the maximum power delivered to the load. Now just check the efficiency also. For efficiency, you require the power. So input power, output power by input power. So what is your input power? That is 10 into 1. So 10 is your V into I. Here we have only one loop. So one loop means I equal to 10 by 5 plus 5. So voltage by resistor. Then we will get like 1 amps. 1 amp. So now we have the Vs value 10. 10 into 1. How much power we have in input side? That is 10 watts. Output power. Output power is depending upon your load resistor. So now your load resistance as well as source resistance both are same. Just substitute those value in this equation. So Vs is 10 by Rs plus RL, both are same. 5 square into your RL value. Then we will get like 5 watts. So how much efficiency we have? 5 by 10. That means 50% efficiency we are getting using maximum power transfer theorem. Draw the graph for load resistance as well as power. So load resistance is increasing. What about power? Is increased as well as decreased. Am I right? So now I have the load resistance as well as power. In x-axis load resistance and y-axis I have the power value. Just substitute those RL is increasing. Then what is our curve? It's increased then decreased. Not zero, okay, it's decreased. Where the maximum point is, that is RL equal to RS. Am I right? And how much efficiency we have? Only 50%. So the maximum input power is 100 watts, but at low resistance we are getting only 50%. So at 50% we have the maximum peak, that is RS equal to RL time. I conclude this session. So maximum power transfer theorem is any linear network, the maximum power transferred to the load. So when the load resistance is equal to the source resistance. Okay. So for this, we have the condition RS equal to RL. That is your main condition. Your maximum power is P equal to V S squared by 4R. That is your maximum power. And your efficiency is only 50%. And your graph will be x-axis is load resistance and y-axis is power. Then your curve will be at maximum. That point is when the RS equal to RL. So this is about your maximum power transfer theorem. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.